Here's the rest of Chapter 6 review answers, starting with number 15. For number 15, we were given that WY is congruent to WU and VW is congruent to XW. So WY is here, WU, and then XW and VW. So I see that I have overlapping parts. So what I'm going to do to make this easier to see is I'm going to actually separate my two triangles. Okay, so I've got this one here, and I've got this one here. And then I'm going to label them just like they were labeled here. So this would be U, W, X, and this would be V, W, Y. All right. I'm going to go ahead and write out what was given. Okay, so I have WY is congruent to WU. So WY, where are you? You're right here, and WU is here. And then VW and XW are congruent. So here's VW and here's XW. So I have two sides. So I either need to find this angle is congruent or maybe another side. Because for two sides in an angle, the included angle has to be congruent. So as I'm looking at this, I see that they both share angle W right here. And so angle W is going to be congruent to itself. All right, so I have angle W is congruent to angle W. And that's going to be the reflexive property. And now I have side angle side congruency for these triangles. So I can say that triangle UWX is congruent to triangle YWV. Again, I was careful to make sure that I kept things in order, so I went down the line with one tick mark to my angle, then two. One tick mark to my angle, two, to make it easier. Side angle side, because these have to be organized when we do this. All right, now I'm trying to prove that angle U is congruent to angle Y. So here's angle U and here's angle Y. They are corresponding angles of these congruent triangles, so these are congruent. 4, angle U is congruent to angle Y, and how do I know? Corresponding parts of congruent triangles are congruent. And that proof is done. All right, for the next section here, we are actually using a different diagram for all of these problems. Oops. So for number 16, we see that angle 4 is 45 degrees, angle 11 is 68 degrees, and angle 5 is what they want us to find out. So as I'm looking at this, I have to see what kind of a relationship do these have. Well, what I see is they're all interior angles of this here triangle. So that means that all of these angles, when I add them up together, they're going to equal 180 degrees. So that's a really good clue as to how to figure this out. So 45 plus 68, 5 and 8 is 13, that's 11. So these two angles added up equal 113 degrees. I need to find angle 5. So I'll say 180 degrees for the whole triangle minus 113. Okay, that's 7 and that's 6. So angle 5 is 67 degrees. Okay, if I add all these up, it'll equal 180 degrees. Add all these up, it'll be 180 degrees. Okay. For number 17, the measure of angle 2 is 55. What is the measure of angle 4? Well, here is angle 2 and here is angle 4. What kind of a relationship do I see between these two? Well, I can see that they're vertical angles. So if angle and vertical angles are congruent. So if angle 2 is 55, then angle 4 also has to be 55. Okay. Now they're saying, what if angle 4 is 70? What is angle 3? What's the relationship between these two angles? Well, they form a linear pair. Linear pairs equal 180 degrees. when they're added together. So I have 180 minus 70 gives me 110 degrees. So angle 3 is 110 degrees. If I add angle 110 plus 70, I'll get 180. Okay, here we have angle 4, angle 11, ooh, and angle 6. So if I have angle 4 is 65, angle 11 is 55, I need this angle. Is there a relationship between 5 and these two angles and between 5 and 6? So I'm looking for a double relationship here. I know that 5 is one of the interior angles of this triangle, so when I add all these up, I get 180. And I also know that 5 and 6 form a linear pair, and when I add these up, I get 180. So let's go ahead and see how that works. So 65 plus 55 is 0, carry the 1. It's 120 degrees. 180 minus 120 is going to be 60. All right, so that means that this is 60, so then this has to be the difference between 180 and 60, and that would be 120 degrees. There's other relationships there too that you might have seen with the math, but this is going to be the way I'm showing you for right now. Okay. For number 20, we have angle 3 is 135, angle 11 is 87. What is angle 5? Again, I see I have a straight angle and I have a triangle. So if I can figure out angle 4, that's going to help me figure out angle 5 as well. So if angle 3 is 135, I have a straight angle with angle 4. So 135 equals, that would be a 10, and that would be a 7. So it's a 5 and a 4. So angle 4 is 45 degrees. So if I do 4 plus 11 plus 5, it would give me 180. So 4 plus 11, angle 4 is 45 degrees. 11 is 87 degrees, and I don't know number 5 yet. So 8 and 7 is 15. Carry the 1. 5 and 8 is 13. So these two are 135 degrees. Okay? And we did it up here already. 180 minus 135 is 45. So 5 will be 45 degrees. Okay. Now we have a little bit different problem here. The measure of angle A is in a regular decagon. We have to find all the measures of all those angles. So what do we know? We know that there are 10 sides in a decagon. And we know that it can be divided up into n minus 2 triangles. All right. So we have 8 triangles times 180 degrees divided by 10 angles equals, I can just say 180 divided by 10 is 18. So 18 times 8 is 144 degrees. If you want me to do all of it, that's fine too. I can say 180 times 8, that's 0, so 4, carry the 6, it's 1440, and then divide that by 10. I'm going to move the decimal over 1 point, so it would still be 144 degrees. So each measure would be 144 degrees. All right. 22. If ABCDEFG is a convex heptagon, find the sum of the angles. So how do we do that? Okay, so we know that a heptagon has 7 sides. So we can do 7 minus 2 is 5. So there's 5 triangles. 5 times 180. So 5 times 0 is 0. 5 times 8 is 40. Carry the 4, so that's 900 degrees. The sum of all the angles would be 900 degrees. Because we figured out how many triangles, multiplied it by 180, 900 degrees. All right. Our next proof, we are given circle P. So that's given. and we have to prove that PAC is congruent to PCA. So what do I know here? I know that PC is a radius, and so is PA. So I'm going to say PC and PA are radii. And that's going to be definition of a radius. It starts at the center point. Circle P means that P is at the center, and these go all the way out to the edge, so they are definitions. All right, so I know that PC is congruent to PA because all radii are equal and are therefore congruent. I should say equals, because again, all radii are equal. If they are equal and they are also congruent, definition of congruent segments. Okay, so I'm going to put that on here. So if both of these are congruent, then I have triangle APC is an isosceles triangle. By the definition of isosceles triangle, it has two sides that are equal. If the two sides are equal, then we know that these two angles are also equal. And so we have angle PAC is congruent to angle PCA. Let's see. And that would be isosceles triangle theorem. Okay, so that is done. All right, now we have number 26. We are given that BDC is congruent to ECD, and that BCD, all of BCD, is congruent to all of EDC. And we have to prove that BCD, the triangle, is congruent to EDC, the triangle. I'm watching the clock here. I only have a couple minutes before it tells me my video is too long. So I'm going to go ahead and separate these triangles out. I have BCD and I have CDE. I see that BDC is congruent to ECD and that ECD, and these two are congruent. Okay, I'm sorry. So I have from my given that these two angles are congruent and then these two angles are congruent. And I also know that CD is the same line for both. Okay, so this is given. 2 CD is congruent to CD by the reflexive property. And I now have side angle side congruency. So I can say angle BCD is congruent to angle EDC by angle side angle congruency. The only way I could see this was by separating the two triangles. All right, and we're done.